circular permutation. Circular permutation is nothing but it talks about number of arrangements in a circle. Normally in linear permutation, the number of arrangements are in linear positioning. That is something like this, right? You can have the object placed like this in a linear fashion. So this is linear permutation. So if there were 4 letters, say A, B, C, D, the number of arrangements for these 4 letters would be 4 factorial. But in case of circular permutation, it is n minus 1 factorial. So if there are 4 letters, then it will be 4 minus 1 factorial, which is 3 factorial. And what's the reason behind this? The number of permutations in circular permutation is always going to be lesser. That's because, say, in a circle you have 4 letters A, B, C, D arranged like this. Now, whether there is no starting point and ending point in a circle. If you read it from here, it's going to be A, B, C, D. You read it from here also, it's going to be A, B, C, D. So from any point you read, it's going to be the same sequence, A, B, C, D itself. So in linear permutation, if you had letter A, B, C, D, and then you write it as B, C, D, A, then C, D, A, B, then D, A, B, C. So in linear permutation, all these 4 arrangements are considered as separate different arrangements. But in circular permutation, A, B, C, D, B, C, D, A, C, D, A, B, all of these are nothing but only one arrangement only. Because there is no starting point and ending point, right? You read it from here also, it's A, B, C, D. You read it from here also, it's B, C, D, A. There is no change. The arrangement is going to be the same. So in linear permutation, if it is 4 factorial, then in circular permutation, it's going to be 4 minus 1 factorial. That is, it will be n minus 1 factorial. So there is also another case where if you don't really distinguish between clockwise and anti-clockwise method of arrangement, then the number of arrangements is n minus 1 factorial by 2. Let's take example for each of these cases, right? First case, in how many ways can 8 colored beads be strung together to form a necklace? So necklace is round. Again, there is no starting point and ending point. You really can't distinguish the clockwise and anti-clockwise beads in a necklace. So in that case, it's going to be n minus 1 factorial by 2. What is n here? N is 8. So 8 minus 1 factorial by 2, which is 7 factorial by 2. Now let's take another example. In how many ways can 10 people be seated around a table? Now you have a table. There are 10 people being seated. Right? Now you can distinguish whether people are sitting in clockwise or people are sitting in anti-clockwise. You can always distinguish. You can figure out. Right? So in this case, it's going to be n minus 1 factorial. That is 10 people. N is 10. So 10 minus 1, which is 9 factorial. Let's take another example for circular permutation. In how many ways can 10 beads of different color be strung into a necklace if red, green and yellow beads are together? So it's told that 3 beads, red, green and yellow, have to be together, right? So we call this as 1 unit because they have to be together. So how many are remaining now? We have 7 beads remaining, right? So now in this 1 unit, how many ways they can be arranged? 3 factorial ways. This is not considered as circular. This is considered as linear because there is no circle formation here. So it will be 3 factorial ways, right? Because it's going to be 3 factorial ways. Now what about 7 beads? Now 7 beads and then 1 unit. So total units is 7 beads plus 1 unit of red, green, yellow beads. So it's going to be 8 units. So total ways you can arrange the 7 beads is 8 minus 1 factorial because this is a circular permutation. Nothing but 7 factorial. So number of ways in which 1 unit can be arranged is 3 factorial. So this is number 1, this is number 2. Now total ways of arranging 7 beads and 1 unit of red, green, yellow is 1 into 2, which is 7 factorial into 3 factorial.